So when using the hollow tool in 3-matic to create a hollowed heart model, you can only assume a uniform wall thickness, but for certain cases you might want to represent the patient's actual myocardial thickness instead of just an assumed uniform value. So in this video I'll show you how to add the myocardium to a hollowed heart model, starting with the segmentation of the myocardium. So to start, I'll click on the new mask button here, and I'm going to choose a threshold range that accurately captures that myocardium. And then I'll hit apply. And I'm actually going to hit this eraser icon here to clear the mask, because we'll then use the multi-slice edit tool to manually select the region of the myocardium and do a local threshold on this region. So I just hit Control M to open the multi-slice edit tool. You can also access it from the segment menu. And I'm just going to start marking every couple slices. And you don't have to worry about staying perfectly within the boundaries, because we will perform a local threshold on this region. And if you'd like to, instead of the circle, you could also use the lasso tool to mark this outer boundary. Okay, and after I'm done with my markings, I'll hit this green interpolate button, and then I'll scroll through the images to check out the interpolation in my selected region. And then I'll make sure my operation is set to threshold, and that my values will be the values that we previously assigned when creating this mask, and then hit apply. So once you've created that mask, I'll rename it myocardium. And then I'll go back to the segment menu and choose Calculate 3D to calculate the 3D object. So once it's done calculating, I'll then bring it over to 3-matic to do some smoothing and add it to the hollowed heart model. So I'm going to hit Control C on my keyboard, select the myocardium 3D object, hit OK, and then hit Control V in 3-matic to paste it in. Now the first thing I'll typically do is under the fixed menu, I'll do a wrap, and I'm going to set a pretty large gap closing distance to fill in all of these holes on the surface of our myocardium, as well as a pretty large smallest detail to get a really smooth surface. So I'm going to use 4 millimeters for the gap closing distance and 1.5 for the smallest detail. And then I'll hide our original myocardium. And now you can see the wrapped version, and I'll go under the finish menu and do local smoothing to further smooth out this surface. And if you'd like, you can also under the fix menu do a reduce operation if the local smoothing doesn't seem like it's being very effective or smoothing very much. Reducing the number of triangles can increase the amount that this tool smooths. So once you have your smooth myocardium and your hollowed heart model, and note that I didn't cut open the hollowed heart model after hollowing it, and that's important in order for this workflow to work properly. So the next step is I'm going to left click on the outside surface of this hollowed heart model and select that surface. I am then going to right click and separate it and move it to a new part. So I'll label this new part our outer surface. And what was our heart hollowed model only contains our inner surface now. I am then going to do a Boolean union operation with the outer surface as well as the myocardium. remove those. And then, so now we have our outer surface as well as just our inner surface. And we then simply hold down left click to drag and drop the inner surface into our Boolean union result. And this is now our hollowed heart model with the myocardium. And then if we were to cut this open, it now has the actual myocardial thickness of this patient instead of just an assumed uniform value. So you can see that there. I also typically recommend, after adding the myocardium, to copy paste this part back into Mimics using Control-C, Control-V like we did earlier. And then you can turn on the contour lines and see how the outer contours of this myocardium corresponds with your images. If maybe your segmentation was off slightly, you could use the contour editing tool to manually adjust that outer surface. So I hope you found this video helpful for those cases where you actually want to represent the patient's myocardial thickness instead of just a uniform value that the Hollow tool lets you use.